If you are dealing with questions involving conservation of angular momentum, here's something that I want to remind you about that I think a lot of students tend to forget, which is that collisions and angular momentum conservation still go hand in hand, just like they did for conservation of linear momentum. So a common example of where you need to integrate collision ideas with conservation of angular momentum is when you have this setup where you have a rod that's laying on a horizontal table and you have like a clay ball that gets shot toward the end of the rod and it collides and sticks with the end of the rod. Whenever you hear that phrase, like collides with and sticks to, the first thing that I want you to think is, okay, this is an inelastic collision. And properties of inelastic collision, so that's like when you have things that collide and actually stick together, is that they have the same final velocity, the two objects involved, and you have a decrease in the kinetic energy in your system. So no matter what, the angular momentum will be conserved, but you have a decrease in your total kinetic energy because it is an inelastic collision. Kinetic energy is only conserved if you have an elastic collision. So don't forget, even with angular momentum conservation, to still look out for those situations where you have inelastic collisions, because that is going to tell you that the momentum is still conserved no matter what, but your kinetic energy is not conserved. So don't forget that about your inelastic collisions.